Good day. Here's a recap of a problem that we discussed in class. I wanted to make a video for this for two reasons. One, to summarize what we did in class, but two, so that we could, I want to point out a couple of students found probably a more efficient way to do this problem. It's the same mathematics, but it's a little bit cleaner and a little bit less complicated, which I'm sure many of you would probably prefer. First, a quick recap. What we established in class was that we can control the price, that's the independent variable, and sales, cost, revenue, and hence profit are all going to be dependent on whatever I set my price at. So what I was trying to do was to establish a connection between all of this stuff. For example, I learned that a $10 price will yield 20 sales, and that gives me $120 in costs and $200 in revenue for a total of $80 profit. We were also able to increase the price, which means we lost two sales, which lowered our cost because we had fewer to make, and it only slightly lowered our revenue because we were selling one more at $18 extra. So now we had a profit of $90. Raise the price again, we lose two more bird feeders, which does lower the cost, and it does lower the revenue, but not as by much. So we lost $8 in cost, and we only lost $6 in revenue, and therefore we have still more profits to be had. Anyway, once we were able to see a pattern here, we can generalize that any price X, the sales can be calculated by simply taking 20 minus the price minus 10. So this is 20 sales less 2 sales for every dollar over $10. And to clean this up using algebra, I distribute the negative 2, and then I get sales will be 40 sales less 2 sales for every dollar. For the same, I can do the same thing for revenue, or for cost rather. It seems $6 is a fixed cost times the number of items made. So we have sales of 40 minus 2x. We're going to take 6 times the sales, or 6 times 40 minus 2x, which distributes out to 240 minus 12x. So there's our cost function, there's a sales function. We can do a revenue function the same way. We multiply the cost times the number sold. $12 times 16 bird feeders, $11 times 18 bird feeders, 10 by 20 bird feeders. So we just do that, and we get our cost function, revenue function. And finally, as it was discussed earlier, the profit is equal to the revenue subtract the cost. So I express that in function terms, and then I just include the cost. Distribute and collect like terms and so on. That created a function, and in class we noticed that the function, just to be sure is correct, I put in $10 and see that I get indeed $80 worth of profit, and that's exactly what happened. So then I just answer the question, which is the easy part. I find the vertex first with the axis of symmetry, and then substituting that value into the calculator, or doing it manually to get $98 in profit. So we charge $13 for a max profit of $98, and that's the problem. Here's how some students suggested perhaps this could be easier. They just studied sales, profit per item, and then total profit. This is in fact a much cleaner way to do it, and the mathematics works out exactly the same. I'll show you. If we start with $10, then we're going to make 20 sales. The profit for one item sold is 10 less the $6 cost, or $4 per item. So if I take $4 times the 20 items sold, I'll get the $80 profit. Similarly, at $11, I will only sell 18, but I'm making $5 per item in profit because the cost stayed the same, but I make an extra dollar for every item I sell. A grand total of $5 net profit. So I'm going to take the $5 but not multiply by 20 bird feeders. Instead, I'm going to multiply by 18 bird feeders because I sold fewer. That does give me, in fact, more profits. Once again, for $12, I'm going to take $20 less $2 for every dollar over 10. So $12 is $2 over 10. That means I lose 4 sales total, and I have 16 bird feeders for sale. However, my profits are $6 per item, and I can then calculate the following. $6 profit for 16 bird feeders gives me 96 total profit. $5 profit times 18 bird feeders is $90 profit, and so on. That can be generalized then. Same way we calculated our sales argument earlier in this video. I have the same exact figure for sales, but what I'm going to do is calculate profit per item first, which is just my price less the $6 per item cost. Then I'll take my profit per item times the number of items, and that gives me my profit equation. And look what happens when I FOIL. I get the exact same equation. You can see right here, this is exactly the same equation that I got way back in first case. So there it is, same equation. We could talk in class about how this right here will end up giving me the exact same equation, but notice we have 6 times 40 minus 2x, and here we have x times 40 minus 2x. We could have made our work simple just by recognizing that those are related. The 16 and the 16, the 18 and the 18, the 20 and the 20 could all be factored out from the difference between price and cost. But I digress. That's a quick little video summary of Monday's lesson, or whatever day it was. I hope you guys have a good day.